Hey everyone, let me share my screen with you real quick. So in this video, let's take a look at topic number 22, proportions. So what is a proportion? A proportion is the comparison between two ratios or two rates. So when we have two ratios that are being compared, so one ratio and one rate, okay? Excuse me, one ratio, right? So two ratio being compared is considered as a proportion. Or this can be two rate being compared. All right. So basically, hey everybody, welcome to topic number 22. So I'm gonna share my screen real quick. So in this video, let's take a look at proportions. So what is a proportion? A proportion is a comparison between two ratios or two different rates. So here, if I have two ratios, okay, they are equal to each other, or two rate equal to each other, is considered as a proportion problem. Okay, so to solve proportions or testing proportionality, we use something called a cross product. So if I got ratio equal to another ratio or a rate equal to another rate, then we will multiply them diagonally. So that will be A times D, sorry about that. That will be A times D, set it equal to B times C, which is BC. All right. I know we haven't talked about solving linear equation yet, but here, the process here is actually not that hard, and I can explain here. So let's solving for the variable using cross product. Enter your answer as a fraction, integer, or mixed number. Okay. So no decimal answers. In algebra, we don't do much decimals. All right. So whenever I see, so basically what's going on here is an equation because the equal sign. I only got two terms, one on each side. Okay, so whenever you got two terms equal to each other, okay, and they are written in fraction form, you can actually use the technique called the cross product. So I normally start diagonally where the variable is. So here we will say 2 times x, which is simply 2x, set it equal to multiply diagonally, just like what I show you up here, 5 times 3, which is 15. All right. So when we're solving equations, if there's only two terms left at the very end, okay, I understand that this problem started with two terms, but when they are written in fraction form, we can use cross product. But here, I also got two terms, okay, one on each side. So this is called a variable term. X is a variable, 2 is called a coefficient. So when you see it like this, variable term on one side, another term on the other side, all you need to do now is divide both sides by the coefficient, which is 2. So my answer is simply x equal to 15 over 2. That's all it is. Okay. Now for this example, I might need to use some calculator here to help me, but let me write it out for you first. So again, written in two terms, written in fraction form, set equal to each other. I can use cross products. So diagonally where the variable is. So I'm going to say 1 over 9 times x, which is 1 over 9x. Set it equal to, multiply diagonally, 1 and 1/3 times 2 and 2/3. 1 and 1/3 times 2 and 2/3. Okay, so multiplication between anything is still one term. Okay, so earlier we said 5 times 3 is 15, so we write 15. But here I wrote it out so we can put this in the calculator. Remember, this is still one term, but between the whole number and the fraction, we have to enter a plus sign. So that's the reason why you want to put each mixed number in the parenthesis by itself. So I start with parentheses, say 1 plus 1 divided by 3, close parenthesis, times, open another one, 2 plus 2 divided by 3. Okay, if you want to do this part by hand, you can. All you have to do is convert both mixed number into improper fractions. So then you can actually reduce top and bottom and multiply. But here, the calculator gonna give me a decimal answer, 3.5 repeating. So I'm gonna write it down. I don't need to convert to fraction right now because I still got one more step to do. So I'm gonna say this is 1 over 9x equal to 3.5 repeating. Even though the last digit says 6, it's supposed to be a 5. Remember I mentioned before, once it go out of the screen, the last digit is automatically being rounded. That's why it rung up, because it's supposed to be another 5 behind that when you go out of the screen. Here is a tricky part in the calculator. So what do I do now? Well, technically, I got variable term on one side, another term on the other side. So it is actually time to divide both sides by the coefficient. So this is called the variable term. X is the variable, 1 over 9 is called the coefficient. So all I'm going to do is divide both sides by the coefficient, 1 over 9. So in the calculator, my 3.5 repeating, or whatever this fraction is already in the calculator. So all I'm going to do here is press divide. But I need to put 1 over 9 inside the parenthesis because it's the entire 3.5 repeating is dividing by the entire 1 over 9. So if I don't use a parenthesis, that means it will divide it by 1 first and divide it by 9 next. So I put them in the parentheses so the calculator know I need to, my answer from the previous line, ANS means answer from the previous line, need to divide the entire 1 over 9. All right, which my answer is 32. Okay, that's all it is. Now, earlier I mentioned about proportion is two ratio equal to each other or two rate equal to each other. So when it comes to application problems, what I like to show student is you put the problem will always give you a ratio start out with or a rate start out with. Okay, technically you're supposed to have two ratios, right, or two rates, but you will start you off with some sort of ratio and or rate first, so where you can put it on the first fraction. So the way I normally show student is make sure you put the numbers with the same units or the same meaning, top to top, and put another two sets of number with the same units or same meaning in the bottom. Okay, you'll be given three numbers, so you need to find one. So the fourth number will have some sort of units on it. So that's how you know where to line up all your units. So let's look at this example right here. In a 121-mile trip to 5.5 gallon of gas. So that is a rate, right? Different units. So they start you off with a rate. And your units are miles and gallons. How many mile can be driven with the full tank of 13 gallons? So this is a typical proportion problems, right? Because if you have more gas, you're gonna end up with more trips. And at home, if you make sweet tea, you are doing proportion. Or if you don't like sweet tea, you like Kool-Aids, you're dealing with proportion problems, right? Because every gallon of tea requires so many cups of sugar. So it's Kool-Aid. Okay, it's not just like keep on dumping the sugar in there, without measure. Otherwise, it'll be very, very sweet at the end. So I'm gonna start off with 121 miles on the top. Why? Because it's first number, it's the first number it tells me. So I'm gonna just put on the top. So when I put 121 on the top, that means I'm putting miles on the top. Okay, 121 miles for 5.5 gallon of gas. So now the bottom is gallon, the top is miles. The question asks how many miles, right? How many miles? So we don't know how many miles, so that will be X number of miles. You see the two units are the same top to top. Can be driven with a full tank of 13 gallon. Same unit, bottom to bottom. Both of these number means gallon. Okay, that's how we set it up. All right, so let's do a cross product. 5.5 times X give me 5.5 X. Is that equal to, multiply diagonally, 121 times 13. Let's see what that is. 121 times 13. 1573. So now I only got two terms. So the last thing I do is always divide both sides by the coefficient 5.5. So with the 1573 on my calculator, divide by 5.5. I don't need a parenthesis for 5.5. 5.5 is just one number, one term. 286. So that tells me that 13 gallon of gas allowed me to go 286 miles. Okay. All right. Same thing. A family uses 3.5 gallons of milk per week. Okay. So that's two different units. That's a rate. That's a rate per week. Per week means 7 days. The reason why I convert to days is because the question is asking how much milk would this family need for 4 days. So it's easier to convert to days. Okay, we'll talk about that in a conversion type of problem. It's easier to convert to days because it's always easier to convert from a bigger unit to a smaller unit. Right, week is bigger than days, right? Week technically is a larger unit than days. So that's why it's easy to convert weeks into days, other than days back into weeks. So here, let's set it up. So the rate start me off with is 3.5 gallons of milk for 7 days, right? Set it equal to. So the question asking how much gallon of milk. So there will be X gallon of milk is for 4 days. So let's do a little cross product. I always start off diagonally where the variable is. 7 times X is 7X. Set it equal to 3.5 times 4. 3.5 times 4. 14. So divide both sides by the coefficient. This is my variable term. 7 is a coefficient. Coefficient only exists within the variable term. So X is equal to 2. There you go. Okay. So that'd be 2 gallons for 4 days. A sugar cookie recipe that makes 3 dozen cookies call for 1.5 teaspoons of baking powder. So the rate is 3 dozen, 3 dozen cookies for 1.5 teaspoon of baking powder. Okay, so 3 dozen, each dozen is 12. All right, so times by 3, so that will be 36 cookies. You can do it that way, or you can just say, okay, this is using dozens, the other one's using dozens, so we can just use dozens for our units. Therefore, we don't have to do any conversion. So the rate is 3 dozen for 1.5 teaspoon. Set it equal to, if I only got 2 dozen of cookies, so when I put 3 on top, that means on the top units are dozen, so I'm gonna say 2 dozen here. On the top, 2 dozen for how many teaspoons? Remember, there's different way to set up proportion problems, but the easiest way to keep up with your units and make sure you're not write the numbers wrong is make sure the units are the same. Same unit top to top, same unit bottom to bottom. All right, so this is 3 times x and 2 times 1.5. So 3 times x is 3x, that equal to 1.5 times 2. 1.5 times 2 is also 3. So if I divide both sides by the coefficient, which is 3, okay, the other number is not the coefficient. Coefficient is always inside the variable term, okay? So my x is equal to 1. All right. Now the next example, every single number is using the same units, but they mean different things, okay? John is investing his money. He think he should make $15 for every $100 he invest. So the $15 representing how much he make. $100 representing how much he invest. So how much does he expect to make on an investment of $4,500? So if I put $15 on the top, okay, these are ratios, right? Because they're all the same unit. If I put $15 on the top, that $15 representing how much money he make over for every $100 he invest. Set it equal to. So how much does he expect to make? So that'll be making X dollars when he invests $4,500. Invest. Okay. 100 times X, 100X. Set it equal to 15 times 4,500. 15 times 4,500. 67,500. So when you divide both sides by the coefficient, which is 100, right? Your answer should simply be $675, right? The zeros cancels out. All right. So let's look at some homework problems. Solving proportion. So remember, I want you to leave your answer as a fraction, okay? Um, you don't have to necessarily go to mixed number for a problem like this one. So the rule of thumb is almost like, okay, whenever we solve for an equation, we try to leave our answer as a fraction, whether it's proper or improper. Okay. So I do want you to try this one right here where you're gonna do cross product. Try to enter it just like I did earlier. Okay, write it out, right? 4 1/5 x, right? Set it equal to 2 1/3 times 1 1/2. I want you to put this in the calculator using them parentheses. And then I want you to, so once you figure out what this answer is, when you divide in the calculator, you need to put this mixed number in the, this is your coefficient. So this mixed number coefficient, I need you to put them in the parentheses when you divide, okay, to come up with the right answer. All right. If Jack jogs 3 miles in 40 minutes, how long would it take him to the nearest minute? So you want you to round to the nearest minutes, okay? When you jog 10 miles at the same rate. So you can set up the proportion. A researcher estimated that the human body contains 88 pounds of water for every 100 pound of body weight. So this is a ratio. This proportion is talking about ratios of how much water in your body for how many pounds you weigh. Okay, so when you first set it up, 88 pounds. That 88 means what? Means 88 pounds of water for 100 pounds of what? Weight, body weight. Okay, so you can actually fill it out. So at this rate, what is the number of pounds of water? So the question is asking for water. So the X should be up here when the person weighs 150 pounds. So 150 pounds should go down here. That's the weight. All right, this problem, I think this problem is going to end up to be a mixed number. So what I need you to do is actually, this actually, what I need you to do is actually enter a mixed number answer. I need you to use your calculator to convert them into a mixed number answer. So let me see if I got some mixed number answer up here. I don't think I did. All right, let's use a 15 over 2 for example. Okay, you could have leave at a 15 over 2. That was fine when you're solving the equation. But for that last application problem, I need you to enter mixed number answer. So as you can see, once I did 15 over 2, right? Once my calculator got set 15 over 2, it's 7.5. So how do you convert into a mixed number? You need to convert into a fraction first. Sometimes, or if you have one of those scientific calculator. If you have one of those scientific calculator, what you do is once you get the decimal answer, like a 7.5, you need to use the F to D command to convert it into a decimal. Okay, the decimal is going to be 15 over 2. So from 15 over 2, then you need the A, B over C to D over E. Anything look like these, okay, will help you convert this in proper fashion into a mixed number, which is 7.5. Now this is easy. This one is easy. But the last question is not so easy for you to just look at and tell. Now for graphing calculator, it's a little bit tricky. Once I register the 7.5 in my calculator, then what I need to do is my whole number is already established at 7, right? So it's the 0.5 is what I'm trying to, it's the decimal places is what I need to convert into a fraction. So I need the calculator to register all those decimals. So I'm going to take away my whole number first. The trick is take away the whole number first. So then once you press equal or enter, then the calculator will display the decimals. Then you can convert the decimals into a fraction. So that tells you that the answer is 7.5 in this case. All right. But for this very last problem, I think the decimal is quite complicated. Okay. I don't want you to round. I need you to give me a mixed number answer. Okay. Let's see if you can use your calculator and figure it out. If you have a hard time doing this problem, figure it out. Let me know what type of calculator you have so I can help you find the commands. Okay, that will conclude this video. Thank you for watching.